All right, thank you so much for joining us today. So we have started vector algebra. We've talked about dot products, right? We talked about dot products, and then we talked about a lot with dot products, and we talked about vector products, vector products. So that's what we're just talking about. And we saw that a dot product, when we dot two vectors, we get what? A scalar, right? We get a scalar. And when we dot, okay, let me do this one cross instead of vector. This one is cross product. And we saw that when we cross two vectors, we get what? A vector, right? So now what we are going to do here is today we are going to talk about scalar triple product. And as the name is going with scalar, it means that whatever we are going to do here, we are going to get a scalar. The idea is that it's kind of a combination of the dots and then the cross product, right? So what we are going to do is, now we know that if I want to cross, let's say B and C, I'm going to get a vector, right? So when I get a vector and I dot it with another vector, then I'm going to have a scalar. So that is basically what you are coming to do here. So here I'm going to dot a cross product with a vector, right? And when I cross this one, I'm going to have a vector. Let's say this is going to give us D, and then when I dot it with A, I'm going to get what? A scalar. So basically, that's what we are coming to do under scalar triple product, right? So let's start with something, right? Now, what we are going to do here is we are saying that the scalar triple product. So let me try and write something for you. The scalar triple product, the scalar triple product of three vectors. So we have three vectors. Let's say we have vector A, we have vector B, and we have vector C, right? Is defined as, so let's try and define what we are coming to do. So I just wrote it for you. So if we have three vectors, so we want to define this. So this is basically this dot this and that. So this is the scalar triple product. This is basically the scalar triple product. And what are we doing here? So we know how to define a cross product, right? For example, if I want to define, let me say B cross C, and then this is basically the same as. So let's assume that my B is equal to B1 plus B2 J plus B3 K, and my C is equal to C1I plus C2J plus C3K. Then when I want to do the cross here, we know what we are going to get, right? First is we are going to define this one as I, J, K, right? And then I'm going to have something like B1, B2, B3, C1, C2, C3. As we learned this one from, I think, the previous video. So yeah, so basically that's what you are going to do. So since we are going to talk about the properties, we'll talk more about this, and you will see that we are going to change something small with what we just learned from here. Now, what we need to also know is anytime we find this, as we said, this is equal to a scalar. So when I dot a vector with another vector, because I know that when I cross B and C, I'm going to get this one. I'm going to get a scalar. This scalar here has a name. This is what we call the volume of this is what we call the volume of a parallelepiped, right? So this is going to give us A dot B cross C, B and C. So anytime I'm working with scalar triple product, the final result that I'm going to get is going to give us the volume of a parallelepiped, right? So that's what you are going to get at the end of the day. So if a question is being asked to find the volume of a parallelepiped, then we just need to think about the scalar triple product. But I have another one too for you. If I want to find the volume of tetrahedron, right? This is just equal to 1 over 6 of the volume of what? A parallelepiped. Yeah, just like that. So this is going to be just knowing that you are taking 1/6 of the volume of a parallelepiped. So this cross that. This is what you are going to get. So these are some of the things that we need to learn. So when we are dealing with the cross product, we saw that when I have um, B cross A and I find a magnitude, I'm going to have the volume of what? A parallelogram. And when I find half of it, I'm going to have the volume of what? A triangle. So when we come to scalar triple product, these are some of the things that also you need to learn from here. So when I just do this one with the scalar triple product, I get a volume of a parallelepiped, and then when I take the 1/6 of that, I get the volume of this one too as well. So basically, yeah, that's what we are going to deal with this. But let me show you something here. There is something very nice that we need to also learn from here. So we are going to talk about the properties. So please have these two things in mind, like these two things here in mind. And then let's talk about the properties. So we have some properties of, scalar triple product. The first thing that I want to share here is I want to share with this one is I want to share that that if we want to talk about, let's assume that um let me just let me start with the first one, right? So we started with this vectors here. So let me start with this one. So we have A dot B cross C, right? Now we are defining A to be A1I plus A2J plus A3K, and then B to be B1I plus B2J plus B3K. And we are going to define C to be C1I plus C2J plus C3K. Now, what are we going to get here? Now, as I said, we know that basically B cross C is equal to, as we said, I, J, K, right? And then we put here B, the first component, right? So B1, B2, B3, C1, C2, and then we are going to have C3 here. So we know that when we do this, we are going to get a vector. So let's assume that when we do this, we are going to get something like D1I plus D2J plus D3K. So if we are getting this, the final result that we are going to get here is what we are going to use to dot this. So basically, this is going to be like, now I have A dot this vector that I'm having here. So this is basically going to give us something like this. A1 I plus A2 J plus A3 K dot. Now when I did this one, I had a new vector because when I cross two vectors, I get a vector. So I'm going to have D1 I plus D2 J plus D3 K, right? So this is what I'm going to get. So when I finish, I just need to dot this and that. So final results here is going to be like A1 D1 plus A2 D2 plus A3 D3. So this is one way of solving this, right? Finding the vector for this. When you finish, then you dot it with A. But we have another way. What can we do with this one? Now this can be written as this is equal to this one here is equal to. So instead of finding um this first, what I'm going to do is I'm going to write this in this form. So how am I going to do that? You see that now we have three of the vectors, and this one we have first row, second row, and third row. So the first row, which goes with I, J, K, is going to be now with the A, right? And then the B will take the second row, and then the C will take the third row, the same thing. So this is going to be A1 plus no A1, A1, A2, A3, right? And this one is going to be B1, B2, B3, C1, C2, and then C3. So that is what we are going to get at the end of the day. So this is how the scalar triple product is going to be with this. So instead of finding the cross for the one in the bracket before we come and deal with the dots, we just put it in this form by picking this to be the first one and then followed by this, followed by that. And when you do this, you are going to get something called a scalar. It should be a scalar, and that's what we call it, the volume of a parallelepiped, right? That's what you are going to get for this one at the end of the day. So with the scalar triple product, this is how you can write it. And we are saying that this is what we called the volume of the parallelepiped. Good, good. So that is basically one property that we need to learn from here. So learn this one here. Let's look at two. What do we need to learn here? Now, there is another nice theorem here that we can talk about, right? We can talk about what if I dot A to B cross C and I'm getting 0. What then happen? What is going to happen? Or let me just also write something like, if I do A this and I dot with this C and I'm getting 0, what is happening here? Then we are saying that these vectors are coplanar. So remember, when we are talking about coplanar, we need to have three vectors that we can write them in what? A linear combination. So anytime you have three vectors like this and you do this and you are getting 0, then we are saying that they are coplanar. So it means that A, B, and C are coplanar vectors. Coplanar vectors. Very important here. So it means that they can, this one, when I'm giving it to you, for example, if a question is given here, I can give you all the values of A1, A2, A3, B1, B2, B3, C1, and C2, but I will leave the C3, then I'll ask you to find for C3 if these three vectors are coplanar. So all I need to do is, since it's coplanar, then it means that here I'm going to have something like this: A1, A2, A3, B1, B2, B3, C1, C1, C2, C3. This should give me 0 whenever it is what? A coplanar. That is basically what we are going to do, right? And this is basically the same as this one also here. Now, when we are talking about coplanar, don't forget another term that we can also use for coplanar. We can say that coplanar is also, we are talking about when these vectors are parallel to each other, right? So we can also talk about parallel vectors, right? And another word that we can use for this one too is when we are saying that the vectors lie on the same plane, right? If they lie on the same plane, like, I mean, if we are talking about parallel vectors, this can be a vector, this is also a vector, this is also a vector. So vector A, B, and C. These are parallel to each other, but we can also talk about when all of them are on the same line, right? So this is like kind of vector A, vector B, and vector C. So this vectors lies on the same line. Then we are saying that they are also what? Going to give us 0 at the end of the day, right? They are also going to give us 0 at the end of the day. So either we talk about coplanar, we talk about parallel vectors, or we can say that they lie on the same plane. So these are the terms that we need to learn them. So you saw that we learned some terms in dot product, we learn some terms in cross product, and we are learning some terms also here. So you need to put them together as you are working with. Right. Good. Another property that we can learn from here is we can learn that, so this is second, this is the third one. This is the third one. Another one that we can learn from here is if A cross B is orthogonal, right? I mean, I think I've made mention of orthogonal before. So when you say orthogonal to A and B, then, so we said orthogonal is the same as what? Okay, you are right. What you said is right. Perpendicular, right? So perpendicular. Right. So if you don't see perpendicular and you see orthogonal, they are the same thing. So if I have two vectors, A cross B, and it's orthogonal to A and B, then this is the same as, this is going to give us A dot B cross this, and this should be the same as B C dot A, and this is the same as B dot A and B, and this is the same as, I think I've made some mistake somewhere. I'll check it there. So A dot B dot. So this one should be AB. There is no C. This one should be AB, and this one too should be AB, right? No, yeah, AB. Good. So if these two vectors is orthogonal, right? I mean, this is the one in the parentheses, right? So they are here. If it is orthogonal to A and B, then when I dot A on the left of this or on the right of this is the same thing as when I dot B on the right and left of this. So that is one thing that you also need to learn. If a vector, so remember, anytime I do A cross B is a vector. So what I mean here is a vector is perpendicular to A and B. Then, so if this is kind of like, this is going to give us D, then this is what we are trying to mean. It's going to be A dot D is the same as D dot A, right? Which is also the same as B dot D, which is the same as D dot this. So that is basically what we are trying to do here when we are saying that they are perpendicular to each other, right? When they are perpendicular to each other. Good. So that is another property that we need to also learn from here. Now let's learn other properties that it's also useful here. Let's learn another property here. Now, another thing that we can learn from here is we have a lot of, things that we can do. Like basically, if we are talking about, so this is the fourth one, A cross B cross C. Now, basically, we cannot say that this is not the same as, let me say A cross B cross C, right? So when you cross this one, you're going to get a vector, and then when you finish, you use that vector to cross the A, you are going to get a vector. It is not the same as when you cross A and B first before you cross with C. They are not the same. So we have a lot of properties that you can also get from here. So with 4, I can also, let me just do 4A. Let me do 4A, and then let me do 4B. This one, if I have A cross B cross C, this is the same as A dot C B minus A dot B C. So this is also another property that you can learn. So if I have this, remember, when I do this, I need to have a vector, right? I need to have a vector. So this is what I'm going to get at the end of the day, and they are going to be the same thing. So this cross this is going to be a vector, and then I do another a vector times a vector, I'm going to get a vector. So what I can do is, now remember, this is kind of like when I dot this, I'm going to have what? A scalar. When I dot this one too, I'm going to have a scalar. Then when I use a scalar to cross this, I'm going to get a vector. And when I use a scalar to cross this, I'm going to have a vector. So a vector minus a vector 2 is going to give us a vector, which is the same thing, right? And then C, we can also talk about another one which is also similar. Let me just swap B and C and have it this form. This is going to give us A dot C B minus B dot C A. So you see that when that's the reason why we are saying that this is not the same as this. So look at this. When I swap this and this here is the same as this, and then this here is the same as this. But when I do that, this is giving us A dot C would be minus, but here is B dot C A, and this is A dot B C. So you see that this and this are not the same. This and this are not the same. So I think you can just be learning the rest, the rest of the thing. Example, we can also see that this and this are not the same, right? So I can write something like, if I have something like A dot let's say B cross C, this is not the same as, let's say, A B dot let's say C, something like this, right? So if I dot this and then when I finish I get a scalar and I used to cross this one, it's not the same as when I dot this and then used to multiply this. They are not the same. So we have a lot of properties that you can also learn from this, right? Let me move to property 5. It's also very important. Property 5, we can talk about equation, right? So equation of the plane. Let me use red to write because it's very important. Equation of the plane. So equation of the plane is giving us a x minus x naught squared plus b y minus y naught squared. Is it supposed to be squared? No, there's no squared. Yeah, there's no squared. It should be just like this. Plus c z minus z naught, and then this should be equal to 0. So this is the equation of the plane. Now we need to look at the terms that we have. So we have a, b, and c, and we also have x naught, y naught, and z naught. So the question is, what is a, b, and c? So I'm going to define them, where a, b, and c are the components of the normal vector. You know normal vector, right? So I will show you the normal vector. So when we talk about the normal vector, so the normal vector is n. I think we did one. I talked about normal vector in the previous video. I think the last example, the trial question that I was giving to you. So the normal vector perpendicular or orthogonal to the plane. So basically we talked about where is it? I even talked about perpendicular here, orthogonal, right? So this is orthogonal. So when you talk about orthogonal, this is orthogonal. Whenever I cross two vectors, I get a normal vector. So that is what basically we are talking about. So this is orthogonal, right, to the plane. So when you talk about normal vector here, so if I'm talking about a normal vector, for example, I can talk about, let's say, big A and big B, right? If I cross A and B, the final result is going to give me a normal vector, which is n, a normal vector. And remember, when I cross A and B, I'm going to get a vector. So when I get a vector, that vector component is going to give me this A, B, and C. We will take example and you understand it better, right? But I'm trying to explain it to you to know the component that we are talking about. So when I cross something like this, and let's assume that I'm getting 2i plus 3j plus 6k, then here my A is 2, my B is 3, and my C is what? 6. Very simple. Very simple. Now, the next question is, what is the component of x naught, y naught, z naught? This is one of the vector which we use to form the normal vector, right? One of the vector that is going to be given to you. So let me just define that. So here, let me just define my normal vector that I was given. So my normal vector is basically equal to AI plus BJ plus CK, right? So that's the reason why when I compare this to this, my A is 2, and this is B, and this is C, right? So that is my normal vector. And then let me just define my other component too for you. So the other component is so full stop here, and so and x naught, y naught, and z naught is the component, or are the component, or let me say is the component, is the component is the component of the, or of one of the points in the plane. Good. So when they give you one of the points in the plane, so let me assume that I'm giving you the plane, like I'm saying that A, B, C are the plane, right? Basically, yeah. So or A, B are the plane. Any point of that. So if I give you AB, you know that AB is going to be like, for example, A, big A is going to be like, let's say, C1I plus C2J plus C3K, right? C3K. So this, my C here, since this is the point on the plane, this is X naught, this is my Y naught, and this is my Z naught. Basically, we will take example and you are going to understand it better. Right. So I think these are basically the properties that we need to learn under scalar triple product, like basically everything that we need to learn from here. So let's take some example and then let's see how we can work with that. So we are given this, this, and that, and we want to determine A dot B cross C. And then when you are done, we find the volume of a parallelepiped with edges A, B, and C. Right. So what is the question? We need A dot B cross C. This is what we need basically, right? So we know that basically A is equal to 2I minus 3J. We don't have K, so this is kind of plus 0K. And B is equal to 3I. We don't have J, so like kind of plus 0J minus K. And our C is equal to 3I. Oh, oops, I think this is wrong. This is supposed to be for C, right? Good. So B rather is I plus J minus K, and this is plus 0J plus minus K. So this is what we have. These are the components for A, B, and C, which is given in the question. So this is equal to the absolute sign. Then first component is my A, because this is scalar triple product. So the first component here is my A, second component should be B, and then last component should be C. So you write them without the direction. So this is going to be 2, this is going to be 2 minus 3, 0, 1, 1, minus 1, 3, 0, and minus 1. Good. So this is what you are going to get. But when you are doing this, don't forget the cofactors. Plus, minus, plus, minus, plus, plus, no, minus, plus, minus, plus. So this is what we're going to get. So let's try and find the determinant. So this is kind of defining the determinant. So this is going to be, if I pick the first row, I'm going to have 2. So when I cancel the 2 out, it will be left with this. So I just write them 1, minus 1, 0, and minus 1. Then remember, this is minus, and this is also minus. So I'm going to have minus minus 3 determinant. When I cancel this and this, it will be left with this, this, that, and that. So I'm going to have 1 minus 1, 3 minus 1. Plus, this is positive, but this is 0. 0 times any number is 0, right? So this is going to give us 0 times. But if you want to write the component, it's this and that. So this is basically going to give us cancel this and this, it will be left with this. So it's going to be 1, 1, 3, 0. But basically, this is going to be 0 because the coefficient here is 0. Okay, let's solve. So this is 2, and let's find the determinant of 2 by 2. So I multiply this one by this, minus, I multiply this one by this. So this is going to be minus 1 times 1 is minus 1 minus 0, plus 3. Same thing here, this times this first. So minus 1. This and this will be minus minus. So this will be minus minus 3, plus this one will just go to 0. So let's just write the 0 there. This is going to be 2 minus 1 plus 3 minus 1 plus 3. This is going to give us minus 2 plus 3 times 2 minus 2 plus 6. And this is going to give us a big 4. A big 4. So we are going to have a big 4. Now, what do we need again? Now, we want to find the volume of a parallelepiped with edges A, B, and C. So, remember the formula for finding the volume of a parallelepiped, right? So, volume of this is basically equal to A dot B this. So, basically, that's what we found here. So the final result is actually the answer that we need, which is a big 4 here, right? So that's what we are going to get from here. So it's kind of very simple. You just need to practice, and you're okay. You know, math is like kind of, if you are starting a new course, you just need to, grab the concept. I mean, the terms that we use in each course so that you'll be okay, right? So try and then get the concept, like the formulas. They are very important, and then know how to solve them too as well. Right. Let's take another question. So here is prove that 4 points A, B, C, and D lie on the same plane. But what was the trick? We learned something basically, I think, right now, and we're seeing that for us to have something like lying on the same plane or lie on the plane, we are talking about what? Let's go to the properties. So is it here? No. It's here. Good. So we said that when you talk about coplanar vectors, or when we are talking about when vectors are parallel to each other or lie on the same plane or lie on the plane or lie in the same plane, any of them is right. So it means that this is what we have. So if we have this, then since we want to show that all the vectors lie on the same plane, then when we cross when we do A dot B cross C, we should get 0. So basically, that's what we are going to do. So from the question, we want to try and do the scalar triple product, and you should be getting 0. If we get all of them to be 0, then we are going to conclude that yes, indeed, A, B, C, D lie on the same plane. This is what we are trying to say. So we have this plane here, right? So we are assuming that we have 1, 2, 3, 4. So we are assuming that A is here, B is here, C is here, and D is here, right? So before we do it, remember when you are talking about scalar triple product, we need 3 vectors. How many do we have here? 1, 2, 3, 4. So we should be able to merge them. So this is how we are going to do the merge. We will merge it from A to B, right? And then from A to C, and then from A to D. So that's how we do it. Always we need to have a starting point and then we end somewhere. So it means that here we are going to look for vector AB, right? So we need to have this vector here, like from A to B. Then we are going to look for vector AC. So also this one. So we have this vector here, we have this one, we have this one too. And then last one is vector AD. So that is how we pair them. You don't pair it like AB, BC, and CD. No, we pick A with B, A with C, and then A with D. So that's how we do it. So this is going to give us, now, before we write this, we need to have the position vectors, right? Remember position vectors, right? So basically, when you're talking about position vectors, if I have A to be 2, 0, 1, then the position vector for this is basically A is equal to 2i plus this one J is 0, so J0 plus K. So this is the position vectors that we are talking about. So this vector AB is going to give us B minus A. This is also going to give us C minus A, and this is going to give us D minus A. So basically, that's what we need to look for. So we need to look for all of them, and then when we finish, we check and see if it's going to be, 0, like this one. So anytime we want to check for coplanars, we need to check this to be 0 or this to be 0. So any of them or both of them should be given as 0. So even instead of saying or, let me do and. Good. So and means that we need to check that this is 0 and this is also 0. Right. So let's finish it up. So we have small a. Let's look for small b. Small b will be equal to minus I plus 2j plus 3k. Small c will be 3i plus 2j plus 2k. And then small d will be equal to 3i minus 6j plus minus 3k. Right, so we have all of them there. So basically what we just need to do is we just need to do some subtractions and then we are done. So let's find for them. This is basically the same as b is minus I plus 2j plus 3k minus a is 2i plus 0j plus k. So what are we going to get at the end? This is going to give us minus I minus 2i. So this is going to give us minus 3i. 2j minus 0j. This is going to give us plus 2j. And then 3k minus k is going to give us plus 2k. So that is for vector AB. Let's look for vector AC. Vector AC is going to be C is 3i plus 2j plus 2k minus a is 2j plus 0j plus k, and this is going to give us, so same thing, this minus this, we have I, this minus this plus 2j plus k. Right, let's do the last one. This is B is 3i minus 6j minus 3k in bracket minus 2i plus 0j plus k. Let's simplify. We are going to have I minus 6j minus 2k. Good. So now that we have the vectors, now we're able to convert this 4 vectors to 3 vectors. Now we are going to now work on what we need. So for the vector to lie on the same plane, then we need to show that one, AB dot AC cross AD is equal to 0, and 2, AB cross AC dot AD is also equal to 0. So these are the 2 things that we just need to do, and then we are done. So if we're able to show that this is true and all of them are equal to 0, then we can conclude that A, B, C, D lie on the same plane. Good. So let's do that. Let's pick them and solve. So I'll start by working with AB dot AC cross AD, right? And then close it. So this is going to be, I have my distance here. So what is vector AB? So that will be the first one. So minus 3, 2, 2. So we have minus 3, 2, 2. What is AC? 1, 2, 1, 1, 2, 1, which is here. And then the last one is 1 minus 6 minus 2. 1 minus 6 minus 2. This. So this is what we are going to do. So basically what we just need to do here is now we need to try and then find the, let's try and find the determinant. So let me just shift some of the things up so that I can have enough space to do the rest of the questions. I want to make sure that the solutions are here. So that's what you are going to get. Okay, let me just move this one to the side and then pick this one and move it up small. Good. And then move this guy up small. Good. Then we can now work with this guy. Good. So let's work out this. This is minus 3. Don't forget the cofactor, right? So always we need to remember the cofactors. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is the cofactors. So all you need to know is always, if we are picking the top one, the j, you need to negate it. So this is going to give us, cancel this. You have 2, 1, minus 6, minus 2, minus 2, cancel this, and we are going to have 1, 1, 1, minus 2, plus 2, then cancel this, we have 1, 2, 1, minus 6. Then we are going to finish this up by saying that, so let me shift it here small, by saying that minus 3 times, so this is going to be 2 times this, which is minus 4. Then when I do this, I'm going to get minus, so it becomes minus 6 minus 2, this times this, minus 2 minus 1 plus 2, then minus 6 minus 2. So let's try and see what is going to happen. Minus 3 minus 4 plus 6 minus 2 minus 3 plus 2. This is going to be minus 8. And then this is going to be minus 3 times 2 plus 6 minus 16. Is that right? Okay. Let's see if you are getting it right. So if we don't get 0, it means that we are wrong. So 2 times this is going to give us minus 6 plus 6 minus 16. This is not 0. So eventually we are having something that is going wrong with this, right? So let's try and check it out with our points and see what is going wrong here. Right. So, oh, okay. I think I've seen it. Is that right? I've seen it. One of them is supposed to be 4 somewhere. Let me see my point. Okay, so let me check my point. My first point is supposed to be -3, 2, and 2. Is that right? Good. My second point should be 1, 2, 1. 1, 2, 1. And my third point is supposed to be, oh, okay. So I think the mistake was here. So this is minus 3k minus k. So this one's supposed to be 4 instead of 2. So this is one way of seeing that we are doing it wrong. So minus 3k minus k should be 4. So this one should be 4. So let's see what is going to change here. So if this one is 4, then this one too will be 4. And then this one too will be 4. Good. So let's do corrections here. This is going to be 8. Is that right? No. This rather is going to be 8 because I'll multiply this by that. So I'm changing it with the blue one. And then this times this is going to give us minus 4. Yeah, so I think that's basically what's going to change there. So this is going to be 8 plus 6. So this should be minus 2. Good. Then this is going to be minus 5. So this should be giving us 10 here. Plus 10 here minus 16. So this is going to give us positive, and this is going to give us 10. And indeed, 16 minus 16 should give us 0. Good. So that's what you're going to get at the end of the day, right? So the first one here is giving us 0. Let us try this one here, right? Let's try this one here using the same. Let me just divide the board into 2 so that you can use this side too as well. So divide the board into 2. Good. So now let's use this side to also work with this one. So this is going to be, so this one is going to be A B cross AC, right? Dot A D. So basically what we are trying to do is like, basically we want to do the cross for this one first. When you finish, then we dot with this one. So I think we are going to have the same components in here. We are going to have the same component because this is basically going to be the same as what we just did. So this is going to be the first component. A, B will be here, right? And then AC2 will be here, and then AD will be here. The same thing as this one. So we are going to have the same component here. Minus 3. Is that right? That okay, let me just write them. Minus 3, 2, 2, 1, 2, 1. And then this is 1 minus 6 minus 4. But let me see what was the component that we did for the first one. It was the same thing. Yeah. All right. So let's just go through and see what you are going to get. Oh, okay. Yeah, I understand now. I understand now. So yeah, we are getting the same component, but there is something small that we need to learn from here. Now remember here, I think I need to show you here the dot product is starting from AB. So we use the first row to handle this, and that. Now, since the dot product is at the last one, we need to use this one here. We need to start it from here. Good. So here we are going to use the last row. So don't forget this one, the cofactor. Cofactor is plus, minus, minus, plus. So basically this one too, the minus will be on the J. So let's see what you are going to get from here. So this is going to give us equal to, so we are using the last row because of where the dot is. Good. So this one will be 1. Then when I cancel the 1, it will be left with 2, 2, 2, 1. 2, 2, 2, 1. Then remember this is minus, so I'm going to have minus 6, minus 6. Then I have this one. Then when I cancel this, I have minus 2, 2, minus 3, 2, 1, 1. Then the last one will be, so let me shape this one small. My board is too small. Okay. Last one will be minus 4. Good. So I get it there. So minus 4 here. Cancel this. I'm going to have minus 3, 2, 1, and 2. Good. So I think basically that is the 2. So here we are starting it from the down because the dot is here. And this one basically we start from the top, which is the same thing as that. Basically, I think you can also rotate this one, right? Because it is dots. You can rotate this, right? Basically, because of it is dot, you can write this one as AD dot AB AB cross AC, right? Because it is a we said that dot product is commutative. So if I have A dot B is the same as B dot A. So basically this is going to give us a vector. So if this is B and this is A, then we can rotate it, right? So that you can put this one on the top and this comes in the middle, this comes down. So you can also do the same thing. So when you finish, you can even check this one out and see if we are going to get 0, right? Good. So this is going to give us 1, 2 minus 4 plus 6 minus 3 minus 2 minus 4, and this is going to give us minus 6 minus 2. So let's see what you are going to get. This is going to be 1 times minus 2 plus 6. This is going to be minus 5 minus 4. This is going to give us minus 8. So this is minus 2, and this is going to give us minus 30 plus 4 times 8 is 32. And this is going to give us 32 minus 32, and we are getting 0. Minus 32 plus 32, and this is going to give us a big 0. Yeah. So basically that is what we need to do. So now that we've seen that this gives us 0 and this also gives us 0, then we conclude that the point A, B, C, D are coplanar or lie on the same plane, right? So that's the conclusion that we need to make here. So let me just write something for you as a conclusion. So we are saying that hence the points A, B, C, and D lie on the plane. So we're able to prove that. Yeah. So basically that is how it's supposed to be. Let me see if we have another question here. Oh, we have 2 more questions. That's nice. Let's check it out. So here, find a constant A such that the vector this, and this are coplanar. Wow, nice. So coplanar vectors, right? We want to find a constant A. This one here, where is the A? Oh, there is no A inside. Okay, so I think this one is not supposed to be A. This one is supposed to be T, because I can see T there. So this one is kind of typo because I can see T here. So this is the T that we are looking for. All right. So we said vector A, B, and C are coplanar vectors. So let me say if A, B, C are coplanar vectors, then A dot B cross C should be equal to 0. So that's basically what we did some here, right? So if they are 3 vectors and they are coplanar, then when I find the scalar triple, I should be getting 0. So now that I know A, I know B, and I know C, I can work it out. So let's work this one out. So this is going to be, what is A? A is 2 minus 1 and 1. What is B? B is 1, 2 minus 3. And what is C? 3, 4, T. So basically that's what I was talking about. So this one will help us to find T, right? So that is basically what we are looking for. So let's do this and see what we are going to get. So I'm using the first row, right? So if I'm using the first row, I'm going to have 2, cancel this, cancel that. We are going to have 2 minus 3, 4t, minus 1, cancel this minus 1 here. We have 1 minus 3, and then let's say 3 and t plus 1, cancel this guy and this guy, and I have 1, 2, 3, 4, which is supposed to be equal to 0. So 2 times determinant of 2 by 2 matrix. So we are going to have 2t minus 12 plus 1. This is going to be t minus 9 plus 1. This is going to be 4 minus 6, and it should be equal to 0. So this is going to be 2t plus 12 plus t plus 9, then plus, okay, this is going to be minus or plus 1, and this is going to be minus 2 is equal to 0. So what do we get? When I multiply the 2 out, I'm going to have 4t plus 24 plus this is going to be t plus 9 minus 2 is equal to 0. So I have 4t, and then I have 1t here. When I combine it, I'm going to have 5t, right? Then when I have, I have 4 here, I have 9 here, I have 2 here. When I do that, I'm going to have, I think, plus 31, right? Because this plus this will be 33 minus this will be 31, and this is going to be 0. And then what will be our t? 5t is equal to minus 31. Divide through by 5, and then our t should be minus 31 divided by 5. Wow, wow, wow. So it means that for us to making sure that when we do this, we are getting 0, the t here should be minus 31 divided by 5, which is very nice. So you see, as we are learning, for you to be very good with it, you just need to practice, with the questions, with the past questions. We have MERBS series also there. I think these questions are basically taken from MERBS series. Some of them are trial questions. Some of them we've solved them and they are already there. So try your best to get one MERBS series and then be working with them. We have a lot of examples. We have a lot of trial questions in there, and then be trying them too as well, right? Because when you practice, that's when you get more understanding. So let's do this last fun math, and then I think we are here. We are done from here, right? So let's try and do this last one. So this is fun, right? So we are trying to solve this simultaneous vector equation where a and b are vectors. So a and b are vectors, x and y are, let's say, some variables. So basically we want to play around with this one, then we close, right? So let's assume that 2x plus y cross a is equal to b, right? Let's assume that you have equation 1, then 2y x cross a is also equal to c. Let's say equation 2. So what I'm going to do is I'm going to multiply equation 1 by y. I will tell you why. So I want to multiply equation 1 by y, and I will tell you what, why. So multiply equation 1 by y, we obtain 2xy plus, so basically we are doing the dot, right? So dot, then y cross b, which is equal to by, right? Good. So that's what you are going to get from here. But do you know some property which is very nice? We know that the reason I was doing that is, we know that if I have a dot a, let's say cross b, basically this is equal to 0. Do you remember this property? This is equal to 0. Is that true? Yes, it is true. Let me go and show you. We just learned the property somewhere here. Properties. Good. So we learned it here. You see, when I have a and then I have a here, if they are the same thing, and then I cross it with another one, this is going to give us 0. If I have the same a inside, it's also going to give us the same thing, because this is what? Orthogonal. Remember, when two vectors are orthogonal, what happens? If a and b, if a and b are orthogonal to each other, then this is going to give us 0. So basically, this is equal to 0 at the end of the day. When we do this, this is the same as this, the same as this, the same as this, and it should be giving us 0. Good. So that was the reason why this I was trying to multiply it by y so that I have the same y going with this one and I'll be getting it to be 0, right? So this, we know that, but y dot y cross a, this is going to be 0. So we are going to have 2xy to be equal to by. And guess what? In equation 2, what should we multiply with so that we get 0? X, right? So we need to multiply equation 2 by x. So multiply equation 2 by x, we obtain 2xy plus x dot x cross a, which is equal to b, which is equal to cx. It's going to give us cx. So we see that this guy here is going to be 0, but x dot cross a is 0, so we are going to have 2xy is equal to this. So let me name this one, let's say equation 3, and name this one equation 4, right? So basically we're able to do something here. So we can solve for x and then put it inside 1, and then we are done. So from equation, let me just put one of the equation in. Okay, so we can even see that, what can we see here? We can see that this is 2x, this is also 2x. So if 2xy is equal to by, and if 2xy is equal to cy, then I can say that from equation 3 and equation 4, we have by, which is equal to cx. Is that true? Yes, because this is equal to this, and the same thing is equal to this. So it means that this is also the same as this. And this one can help us to find for y will be equal to cx divided by b. Now, let me say this is equation 5. I know I'm getting a lot of equation. Let me put equation 5 into equation 2. Put equation 5 into equation 2. What is equation 2? This is equation 2, right? Here. So I want to put it in, I want to put it there so that I can find for x, and then when I get x, I'll just put it in other equation to find for the other one. So this is going to give us equation 2. Let's put it in. So this is going to be 2x divided by b plus s cross a, which is equal to c. We know that equation 2 is 2y plus s cross a is equal to c. So we are just putting this one in place of the y. So 2 times y, which is this, and then this, which is equal to this. So now let's make x the subject from this equation. Let's make x the subject from this equation. So let me copy this to the next page, and then we continue from there. So this is going to give us 2 divided by b plus is equal to c. I'll dot through by b because I have this b here. Dot through by b. So I'm going to have, when I dot it, I'm going to have 2cx plus b dot x cross a, which is equal to bc, right? It's kind of, I want to multiply through by b. So this one will cancel this, multiply this one by b, multiply this one also by b. So this is what I'm going to get. Let me write my x well so that it can differentiate from this one. Now I can factor this guy out. So I will just factor x out, and to be left with c plus b cross a, which is equal to bc, and then x will be equal to bc divided by 2c plus b cross a. But the question is, I know some people will be asking question right now. Let me try and clarify that. So you saw that I was able to factor, I have 2c plus b dot x cross a, right? And I was able to factor s out. How did I do that? You know, if I have something like this, right? This is going to give us like, you have two scalars, right? So we said dot products, like if I want to dot a and b, a and x, this is the same as x dot b. So basically I can write this one as x dot b cross a, right? Then I factor the x out. So when I factor the s out and I multiply it back again, I will come and get my dot. So that's basically what I did from there. Then what I'm going to do here is, now that I have this, let me call this one equation 6. I'm going to put equation 6 into equation 5. Put equation 6 into equation 5. What is equation 5? Equation 5 is where we make y the subject. So we said y is supposed to be equal to cx over b. So we know that y is equal to c over bx, right? So basically we just put it in and then we are done. So y will be equal to c over b. X is bx divided by 2c plus b cross a, and boom. If I want to just simplify, I'm going to have something like this. Let me see. Yeah, I think this guy can cancel this guy here, and I can have c squared. What was c? C is a vector. So can you get a vector squared? No. Can you have a vector squared? Yes, we can have a vector squared. So I can just write it that way. I have 2x plus b cross a. So this is my y. So basically what we just need to do is just wanted to make some fun at the end of the video. So we're able to find for x and y from this, which is nice. Yeah. So basically we're trying to eliminate, or we are trying to making sure that y is standing alone and then x is standing alone without having them. Yeah, so this is the end of the video, and I think in the next video we are going to solve some couple examples on what we've learned. And then when we are done, what we are going to do is, I'm going to, before we move to unit tangent and other stuff, we are going to talk about line intersection, equation of the line, before we move to those kind of questions, right? So see you in the next video.